In this video, we are going through the November 2022 Maths Grade 12 exam from start to finish without leaving anything out. Now, the big idea is regardless of whatever syllabus you are currently doing, this paper is going to give you a good idea of what you can expect in your final exams if you're in grade 12. So without wasting any time, here we have question number 1, right? Question number 1, it says we need to solve for x. Solving for x, we need to solve for x, leaving our answer correct to one decimal place if necessary. So the idea is anytime they're going to ask us to solve for x and correct to one decimal place, we may obviously need to remember that we're going to need our calculator so that we can get the decimal version of whatever answer we get. So fortunately, each of these brackets, it's already factorized nicely, hence why it's equal to 0. Now we know that whenever you have two brackets and they're being multiplied together and they tell you that you're going to get an answer equal to 0, it means that one of the brackets is either a 0 or both of them is a 0. So because you don't know which of these is a 0, you have to work out where each of them is a 0. So the first one, you take the first bracket, make it equal to 0. We're getting here 1 with 3x left. Divide everything by 3. You're getting x is a third. They said we should leave our answer to one decimal place. So you need to be very careful in this kind of situation. So writing this to one decimal place in your calculator, you can just put 1/3 in the calculator. To one decimal place, it is just giving you here 0.3, bro. Come on. The other one, which is this bracket, 4 minus x is equal to 0. The x goes over. To one decimal place, you can just say 4.0, just for the vibes. But anyways, let's keep moving forward. Nothing crazy about this question. This next one is asking us to solve for x again, obviously. Solving for x here, normally you would want to see a situation where your bases are the same and all that. However, excuse me. However, in this kind of situation, we don't have that kind of a luxury. So we have to use logs for this question. Now, when you use logs, the idea is you want to isolate your exponent. When you isolate it, you make it equal to log. The base of your exponent is the base of the log. This value here is this value there. Now, obviously, you can divide everything by 3. Divide here by 3. Divide this whole thing here by 3. And then what you're going to get from that, let's see here, divide by 3. X is going to be left on its own. You're going to have your log with the 2 here and the 7, everything over 3. Obviously, when I put this in your calculator, fraction button, log with the 2, 7 there, and the 3 at the bottom there. So this is giving you an answer of 0.2 to one decimal place. It's going to be 0.9. Now, obviously, if you spot any funny typos or anything, you can just let us know in the comments, and then we shall, acknowledge that. So thank you very much. Anyways, moving forward, we have here, they said we should solve for x again. So in this kind of an inequality question, what you need to do is you need to obviously put this equation, because this equation has the left side somewhat the way it is. This is the kind of a scenario where you don't want to get overly excited and you just leave it out or something like that. With this kind of inequality questions, all you want to do is you want to see what kind of a quadratic equation you're working with, so that you can draw like a rough sketch that will help you answer this kind of question. So getting our parabola here, we're just going to multiply inside the bracket here. It's going to be x squared and then minus x. The negative, the 20, you can bring it over, right? So the reason for doing this is you're seeing that this is just a parabola. This question is asking you, where is this parabola below 0? So first things first, right? This is a smiling parabola. So this smiling parabola will look something like this. So while it's looking like this, right, the idea is your x-axis is somewhere there. They're asking you, where is this graph below 0? Your graph is below 0 over here. You see? Now, since they're asking for the x values where the graph is below 0, you're going to say it's below 0 starting from this x value up until this x value. So we have to find what those x values are. finding those x values, we just have to solve for x here by making this equation equal to 0, you see, to make it equal to 0. So fortunately, this we can factorize easily, because factors of 20 that give us a 1, it's 5 and 4. But then to get a negative 1, you have to say a minus 5 plus a 4. You see, these are giving us our critical values, which is our first x-intercept over here, which is a negative 5. Our other one over here, which is a positive 4. So your answer here, you're going to have to say that the x values are bigger than negative 5, or your x values are below 4. You see, so the big idea is, with a situation like this one, right? This is the first x value, negative 5. If you move to the right, up until 4, all these x values here are resulting in these y values down here. So let's move on. B says, determine the values of p, right, for which the roots of this equation are real and equal. So if your roots are going to be real and equal, you have to consider where b squared minus 4ac is equal to 0. So you see, nature of roots questions, you obviously need to know your work when it comes to those kinds of questions. So you always want to put this in quadratic format first before you can make use of this equation. So putting this in quadratic format, you can multiply inside your bracket. You can have x squared minus 6x, and then the 2p can come over. That's going to be negative 2p equal to 0. This is in quadratic format. You can easily see that a is a 1 over there, b is a negative 6 over here, c is a negative 2p over here. So all this being done, let's see here. We have to put all that information into this equation. So it's going to be negative 6 squared minus 4. Our a value is a 1. C value is a negative 2p. There we go, equal to 0. There we go. Well, come on. So that being said, let's solve for p. This is 36 plus, let's see, 4 times the 2 is 8. With the positive values, so positive 8p equal to 0. 8 stays on its own. 36 goes to the other side. So this here, divide by 8, divide by 8. Our p is equal to 9 over 2. So remember, they say determine the values of p for which the value or the values of p for which this equation has roots that are real and equal. So it's a formal question. We're only getting a single value. So for your roots to be real, right, this obviously has to be bigger than 0. But then for them to be equal, this has to be equal to 0. So wait. So but because here they said roots have to be real and equal. Yeah, the end part limits us to this only. We cannot work out where b squared minus 4ac is bigger or equal to 0. But then hold on though. Roots are real and equal. It's kind of funny because if you think of it, if they say roots are real or equal, then but you know what? To be on the safe side, if they say determine the values of p for which the roots of this equation are real and equal. Yeah, let's deal with where this is bigger or equal to 0. Because they are real where it's bigger than 0, they are equal where it's equal to 0. So let's just, change this to bigger or equal to 0. Meaning that this here in the middle can have bigger than or equal to 0, bigger than or equal to 0, bigger than or equal to 0. Perfect. So we're going to get our 4 marks there. Let's keep moving forward. Number 2. Question number 2 says, solve for x if this equation is equal to negative 2. So this kind of an equation, I mean, obviously you need to know your third laws. So remember, in a situation like this, if you have, let's say, a variable to the power of a third, or rather, let's use a half because that's what everyone is used to. If you this 2 down here, right, you can take it outside the square root symbol, and then the exponent, the one up there, stays inside. You see, that's why these are equal to each other. That's why they always say anything under square root can be written to the power of a half, because all that happens is the 2 out here goes under the 1 down there. So if you're going to go from here to there, the 2 here goes outside, the 1 stays with the A. So that's logically speaking what is actually going to happen when you have a scenario like this, right? If you have, let's say, A to the power of a third, the 3, you can take it out here, the 1 can remain inside over there. That's the idea we're going to use over here. This here, we're going to put it inside a cube root with the 3 out there, and then a 1 over here. And then this is equal to -2. So by doing this, you may be asking yourself, but then why did we do this? The reason we did this is so that on this side, if you want to get rid of a cube root, you have to cube one side and then you have to cube the other side. And a negative number can be put with the cube like that. But anyways, let's maybe write that step in the next line here. You see, oh, this thing here, we're going to cube it to get rid of the cube root there. Same here. You see, this is going to give us a -8. And then on this side, this is going to cancel that. So x minus 3. The -3 goes over. It's going to be -8 plus 3. That's a 5. No, -5. I mean, another way you could have done it is in your calculator, you could have just put like a symbol like this with a third over there in the calculator. And then here also a symbol like that with the third here in your calculator. It would still have worked out. You would then have been left with this step here. Oh, snap, made an error. It's a plus, it's a plus, it's a plus. Meaning when it goes over to the other side, you minus. So that's -11. Yeah, so just always look out for the way you rewrite your answers, because yeah, if you get it wrong here, they're gonna just see your final answer and mark it wrong. They're not gonna consider how you wrote the question incorrectly. So yeah, I think as we go along, we're just gonna need to be double checking as best as you can. So obviously, as you can hear, it is not a robot going through the paper. So if there are like typos here and there, it's just a typo. You can just keep going through the paper. It's like if you're eating, meat with the bone. When you hit the bone, what you do is, you chuck the bone, but you keep eating the meat. You don't throw away the meat with the bone. But that's a weird analogy. But anyways, let's carry on. For 4 marks here, they're asking us to solve this log question. So the idea is, fortunately, our logs both have a base of 3. So here we can be reminded of the quotient rule, meaning if we're subtracting and our base is the same here for our logs, we can divide, meaning we're going to have log with 3. Inside, we're going to have x plus 5. And then down here, the x. This is equal to 1. That's your quotient rule of your log laws. So here, obviously, you want to reverse all these things here to get rid of the log. So remember, your base here is what you'll have as the base of this number. And this here will be on the left-hand side of your equation. So this is just a 3, you see. So this 3, let me just deliberately write it as 3 over 1. And then here, let's just write this as x plus 5 over x. Because our next step, we just have to cross multiply. X times 3 is like 3x. 1 times that is like x plus 5. Let's put the x's where the 3x is. And then we have 2x here. Dividing both sides by the 2. You're going to have here 5 over 2. Now, obviously, when you get answers like this, the least you can do for yourself is to just double check your answer by putting your value of x in your original expression. If you put your value of x in your original expression, the equation should just balance out. If it doesn't balance out, it means there's something wrong. But if it does balance out, then it means you did your work correctly, as you should. So it balances, so we move on. See, here says, if w is equal to this expression, then for what values of x is w non-real? If w is equal to this, for what values of x is w non-real? For w to be non-real, the value under your square root symbol has to be a negative. You see, that's why this is just a 2-mark question. For anything under a square root to be non-real, whatever is under that square root has to be below 0. So we have to work out where this is below 0. So this is below 0. If you take x to the other side, it's below 0 where x is bigger than 7. if x is bigger than 7, you're going to be saying 7 minus a number bigger than 7. So you always get a negative value under the square root symbol, meaning your values for w will be non-real, meaning they don't exist. For question 2, it says, solve for x if w plus 2 is equal to x plus 1. It's a how many mark question? It's a 5-mark question. So this is a 5-mark question, meaning we need an actual value for w. But the thing is, in a situation like this, don't overthink it. You can actually know that we need to solve for x. So we can try firstly by isolating x. All things considered, let's isolate x first. The 1 can go over to the other side. It's going to be 2 minus 1. You have w plus 1 here, right, equal to x. Now, if you're going to solve for x, right, the idea is you will be asking yourself, but what value of w are you going to choose? So the funny thing here is, what you call the previous question and this question, you can almost think to yourself, there has to be some kind of a relationship, because if x is bigger than 7, then w will be non-real. Here they're saying solve for x if w plus 2 is equal to x plus 1. So I mean, like, the thing is, x here, right, has to be bigger than 7. So for x to be bigger than 7, you can think to yourself here, if x is bigger than 7, right? For x to be bigger than 7, you can see that your value of w has to, I mean, logically speaking, the way this is looking, it seems like a simple question, but then the thing that obviously may be a bit unsettling is the fact that it's a 5-mark question. So it being a 5-mark question, you'd be thinking, but where are the 5 marks going to come from? Because question 2 in particular, it's like 2 marks, plus the 4 marks, that's 6, plus 2, that's like 8, plus 5, that's like 13. So for a 5-mark question, you may be wondering, wow, what do we even need to do? Because here they said we need to work this out. Fortunately, what we do know is we have a value for w here, which is this expression. So let's just throw it over there. You see, square root 7 minus x plus 1 equal to x. Solving for x here, I mean, logically speaking, yeah, I think from the get-go, it may have been better to, let's just carry on from here. The 1, you can take it over to where x is. The reason for doing that is you want to get rid of the square root symbol. I think if you had just thrown in your value of w from the beginning, it would still have been fine. But here we are. Here, we can square both sides to get rid of the square root. The moment you square both sides, right, you have to be careful here. You can just keep in mind that your answers, the answers that you get, make sure that you test them, because normally one of them works. Anyways, from here, x times x is x squared, and then x times negative is a negative x, another negative x, positive 1. 7 minus x. This is like x squared minus 2x plus 1, 7 minus x, right? And then everything on one side, x squared minus 2x plus 1, 7 on the other side also, x on the other side also. Then you have here x squared, this and this gives you a negative x. 1 minus 7 gives a negative 6. Fortunately, here it looks like you can factorize, because factors of 6, that give us a 1, 3 and 2. To get minus 1, you have to say minus 3 plus 2. There you go. So here, our x minus 3 is equal to 0, or the x plus 2 is equal to 0. So fortunately, here you can just say x is equal to 3, or x is equal to negative 2. The only issue is, you see here, our answer says x has to be bigger than what you may call. It says here x has to be bigger than 7 for the values of what you call, for which it says if w is equal to this, then what values of, then for what values of x is this non-real? So fortunately, this question in particular, right? I mean, even though w is equal to this value, if we have our specific value of x here that is equal to 3, if you look nicely, this is going, wait, hold on. Did I write this correctly? X is bigger than 7. Oh, that's if it's none. Yeah, if x is bigger than 7, your roots your answers will not be valid. But then obviously, here we have x values that are smaller than what you call than 7. So they should both work out. But you have to test them in this equation here. They have to balance out this equation. If they don't balance out this equation, you have to disregard it. So let's try the 3 first. So square root of 7 minus 3, right? Obviously, if you add a 1, that's going to give you a 3. So those balance out. And then square root of 7 minus, let's try negative 2. If you add a 1, that's going to give you a 4. So that does not balance out. So you have to disregard the negative 2, you see, because the negative 2 does not work out. So that's why you have to test out your answers, you see. So all that being said, let us keep moving forward. Let us keep moving forward. Let us keep moving forward. So let's see here. Let's keep moving forward. So moving forward, right? We have here question 3. Question 3 says, using first principles, find the first derivative of g. So that's a harmony formal question. So that's straightforward, because your first derivative will be equal to lim h goes to 0, x plus h minus g x over h. Now, in this situation, it doesn't seem like we have a difficult question. So let's just throw in our value for g. This is just saying in the equation of g, wherever you see x, throw in x plus h. You see, so here it's going to be negative 3 x plus h squared minus, if it's a negative and a negative, you see this negative times negative 3x squared is going to give you a plus 3x squared, the whole thing over h. And then obviously everything here we can just carry on nicely. Here the negative 3 is outside, but then here, right, x plus h squared is going to give you x squared plus 2xh plus h squared plus 3x squared, the whole thing over h. And then lim h goes to 0. If you multiply inside, you're going to have negative 3x squared plus 2xh plus h squared plus 3x squared, the whole thing over h. Now, everything that will be here, right, needs to be cancelled by something here. Otherwise, we'd have done something wrong, you see. So the whole part here where we're cancelling this and this, you always need to see that for every equation that asks for the first principle. That's like a given. So from here, you can take out h as a common factor, and then take note of how we're keeping this whole lim part out the whole time. So h goes out, this is 2x plus h, the whole thing over h here cancels h. And then this is like 2x plus h. Now you can put in a 0 where h, no, something is wrong. Error, you see, because when you multiply inside, it's supposed to be a 6, a negative 6 to be exact. Yeah, ne? Wow. Negative 6, negative 6. Because I'm just looking at the final answer here. It makes no sense compared to what the original equation looks like. And yep, the boy is going through this paper on an empty stomach. So yeah, it is what it is. But let's see. If you put 0 where h is, you're gonna have here, therefore, your first derivative is just negative 6x. So spotting the error was literally because in the beginning, your mind should already see that when you differentiate this, it's going to be 2 times negative 3, which is negative 6, and then x, because the 1 is removed from the 2. So if you make small errors here also, you see when I multiplied inside, I don't even know why I didn't multiply the 3 here also, because this would have been like -3. You is a weird error. This is like -3. What a wow, bro. And then this is like -3. Fortunately, this does not affect anything because yeah, it is what it is. -3 over there. So that's still okay. Dude, there would have been, yeah, this would have been a -3 thingy, 6. Yeah, so that was kind of awkward, but let's move on. Let's move on. Let's wake up and move on. It's a formal question next. So whatever we're doing now, you have to remember that the detailed explanations of these topics, right? You can find them on the course website. The link to that is in the description, of which, as of this recording, there is a sale for just 99 Rand to get access to all the topics, so your entire syllabus. You say functions, calculus, Euclidean geometry, trigonometry, analytical, financial maths, probability, statistics, the whole shebang. Here they want us to find the first derivative. Finding the first derivative, you have to put this in a format that we can differentiate. So that format, fun enough, this is just 5/3, right? The x is to the power of 1. So you can take it next to your fraction. And you can put it as an exponent with, you can put it with x to the power of -1. This x here, you can take it next to your fraction, like this. The next part here, the 3 here can go under the 5, and then the square root, you won't have to write it. So here it's going to be 5/3. So here now, now you can differentiate, because the format is something that you can differentiate. -1 times this is like -5/3. Removing 1 from the exponent, that's -2. 5/3 times 1, that's like 5/3. Removing 1 from the exponent, that's like 2. There we go. Now you can leave this the way it is. It's a formal question. They'll give you marks for simplifying, they'll give you marks for differentiating. Okay, if they want you to leave your answer with positive exponents, you can take it a step further. You can take this back down to where the 3 is. It gets a positive exponent. This already has a positive exponent, so you won't have to do anything there. It's fine just the way it is. Let's see here now. It says, in the diagram below, you have a parabola. Yes. And they say it here, A, yes, is the y-intercept, and B is the x-intercept. Yes. Calculate the coordinates of A and B. You see, the one thing I'm always checking before we start is the mark allocation. So fortunately, A and B, it's just the y-intercept, x-intercept. So easy marks there. Ooh, somebody's hungry. Give me food. I mean, please. What? That was like, give me food. I mean, please. It is what it is, bruh. I'll eat when I'm done. But for now, let's finish. Let's finish. So, but obviously, when you go through an exam, if you're gonna go to write your exams, just make sure you have eaten. And also at home, if you're going through past papers, just make sure you have eaten, because you almost want to like simulate the scenario of the day you write the exam. Yeah, just do what I say. Don't do what I do. I'm talking about writing a paper hungry though. But anyways, let's say here, calculate the coordinates of A and B. So A is just a y-intercept. You have to make x a 0. Fortunately, we can see it's just a -3 here. So it's okay. Let's just do the things that need to be done. So this is like -3, right? There you go. So B, it's gonna be, you make y as 0. So here you can say A, x value is 0, y value is -3. For B, right, you make y as 0. So this is gonna be a 0 equal to x squared minus this minus 3. So factors of 3 that give it 2. So let's see if this can be factorized. So factors of 3 that give it 2, it's just 3 and 1. But to get a -2, you have to say a -3 plus a 1. There you go. So this makes sense, because now at least you can say x minus 3 is equal to 0, or x plus 1 is equal to 0, which makes sense because clearly visually it looks as though this is going to be a -1, this is going to be a +3. Now, just for interest's sake, in the middle of our two x-intercepts is where our x value of our turning point is. But that's the equation of, this is the line of symmetry. It's in the middle of the -1 and the 3, which is technically at 1 here. But it's okay. Let's move on. No, we have to fill in coordinates. So B here, it's the one where you have a positive 3, you see. 3 and 0. There you go. Let's write this nicely. B. There you go. So determine the coordinates of the point on F, where the tangent to F is parallel to line AB. Let's start again. Determine the coordinates of the point on F, where the tangent to F is parallel to AB. So we're talking about a tangent that will look like this. Let's see. Yeah, a tangent that will look something like that. Or rather, let's even make it even fancy. A tangent that will look something like this, but then the tangent is going to be down here. So if you're going to get the equation of that tangent, the fortunate thing is a tangent is just a straight line. So if you want to get the equation of a straight line, the equation is just y is equal to mx plus c. When you're going to be working it out from scratch, you can use this format: y minus y1 is equal to mx minus x1. x1 and y1, that's just the coordinate that the graph passes through. And then m is your gradient, you see. Now, the fortunate thing is the reason why they have told you that this line is parallel to AB is because you can get your gradient from AB. And then once you get your gradient from AB, you obviously need a coordinate that the graph passes through. Now, getting a coordinate that the graph passes through, you need to be creative. Getting a coordinate that the graph passes through, you can see that this point is a point on the curve. Now, the point on the curve here, you can get it by using your gradient of your tangent. Because remember, a tangent, this is one thing you always hear me say on the online courses or wherever you'd have heard me talk. Wherever you'd have heard me talk. Wow, that's weird. Here, a tangent, right? And the curve, which is our parabola, they share a gradient, you see. So once you have the gradient of your line here, you can find out what the coordinate is at this particular point by putting that gradient into the gradient equation of the curve. Now, the gradient equation of the curve is your first derivative. But let's do it bit by bit. Let's firstly get the gradient of our parabola first. Getting the gradient of our parabola, we need the gradient of AB. So y2 minus y1, x2 minus x1. Mark allocation, let's see. 5 mark question. Okay, let's go. So we have A and B, right? We can just say -3 minus a 0 there. -3 minus the 0. 0 minus the 3. 0 minus the 3. This -3 minus a 0 is a -3. 0 minus a -3 is like -3. So this is just canceling each other. You have a +1. Gradient is a AB. The gradient of AB is the same as the gradient of our tangent. Now, what we are saying is, since the gradient of our tangent is the same as the gradient of our curve, the gradient there is a 1. You see, so if the gradient there is a 1, we can find out what is the coordinate over there, because we need that coordinate to put over here, right, for us to eventually get the equation of our straight line. To get this coordinate, we can use the fact that since the gradient is a 1, let's firstly find out what is the x value over here using our gradient equation, which is our first derivative of our curve, you see. So in our first derivative of our curve, let's get that first before we carry on talking. The first derivative of our curve, right, is giving us an equation that will allow us to use the gradient to get the coordinate. So this is like 2x, because you see 2 times x is 2x, and then here, removing 1 from the exponent, you have 1 over there. Then you have 1 times -2, and then removing 1 from the exponent, you have the 0. And then this last part falls away because a derivative of a constant is 0. So here now you have the gradient equation of your curve. You want to work out where the gradient is a positive 1. You want to find out what is the x value. So doing that, the 1 here, you plus the 2 there, it's going to be a 3. Divide both sides by a 2.
As of this recording, the All Access Pass, which allows you to access everything on the website, is currently on sale. The sale will give you access to the online courses for a total of 60 days. Now, the All Access Pass includes the entire syllabus, everything for paper 1, everything for paper 2. You have video lessons that are preloaded on the website, meaning that you'll be able to go through all these video lessons at your own pace, at your own time, without worrying about anyone necessarily scheduling any sessions. Now, the link in the description will take you to the course website where you'll be able to make a purchase of this bundle. The sale is ongoing between the 23rd of October until the 7th of November. Depending on when you're watching this, I suggest that you hop onto the course website and make a purchase. You can purchase directly on the website using a credit card, debit card, or you can make a purchase via the EFT details that are provided on the website. As a reference, you should put in your name and your surname and send the proof of payment to the email address listed on the screen. For more queries, questions, you can always just contact us via WhatsApp. If you would like to find out more information about Bright Young Brains, you can always just Google us and you will be able to find more information regarding what it is that you would want to find out. Depending on where you're currently residing, you can always just contact us via the contact details that you see on the screen.
This is 3/2. Now, with that being done, right, you need to keep in mind that as long as that is now done, what you now know is the x value there is 3/2. Since you now know the x value there is 3/2, you can now use your coordinate equation to find out what the y value is. So in our coordinate equation, let's see what we can do there. We're putting there 3/2 and 3/2. So this is like 3/2 squared, and then again another 3/2. And then here we have -3. Now, in your calculator, let's see what we're going to get here. 3/2 squared. And then 3/2 that -3. That's like -15/4. -15/4. So this is telling us the coordinate where the graph is meeting the tangent, which is over there. Whew, what a wow. We are moving. So with all this being said, well, I feel like there was not enough space for it. Or maybe I'm just writing big. So all this information being said, right, we can now make use of our equation over here to get the y-intercept of our graph. So from here, we can say y minus the y value, meaning with plus. And then here, gradient is a 1, remember? X minus x1 is just 3/2. Let's simplify. This is just going to be x minus 3/2. This goes over. And then in your calculator, you want to say this value minus that value. So it's like -3/2 minus 15/4. That's like -21/4. There we go. So that's what we have to do next. So with that all being said, wait, what has happened here? Bro, come on. This is the y-intercept, yes, but the equation has the x here. You see? There we go. X minus 21 over 4. That's your equation of your tangent. Ha! They just wanted the coordinates. I went overboard. Wow, bro. Determine the coordinates of the point where the point on F where the tangent is parallel to. They just wanted this here. Oh, goodness. Bro, this was not necessary. Like, this was not necessary. Goodness. All we had to do was to get the coordinate where the tangent meets the curve. Oh, that's why it was seeming like there was not enough space. Oh yeah, so this is where you'd end up then. I'm always used to getting the equation of a tangent to a curve. That's why I went overboard. But anyways, here this is the coordinate. Therefore, the coordinate is 3 over 2, negative 15 over 4. But then I guess this was just an extra bonus where I showed what you would then need to do to get the equation of the tangent. Okay, it is what it is. It's okay. Let's move on. Question number 4. What do we have here? It says, the nth term of an arithmetic sequence is given by this. Okay, that's nice. Determine the number of terms in the sequence if the last term is 198. Straightforward question. So this is the position of this is the last term, right? They want us to find the number of terms in the sequence. So simply put, all you can do is Tn, you make that 198. And then us solving for n will be us finding the position of this last term. If we find the position of this last term, we find out the number of terms in the sequence. You see, this can go over, it's a plus, so it's going to give you 200. Divide everything by 5. You're getting here 200 divided by 5, right? 200 divided by 5. Let's see what we're getting here. It's like 40. 40. Therefore, there are 40 terms. Question number 2 says, determine the sum of all the terms of the sequence. So determining the sum of all the terms, you're just going to use your SN formula. It's also an arithmetic formula, so it's an arithmetic sequence, so this is the formula you use. It's on your formula sheet. So here you have to keep in mind that the number of terms is 40. Your first term, you can get it from your general term, right? T1 is going to be equal to 5 times 1 minus 2, which is just a 7. See, that's your first term. So let's just make sure we put that down here because we is needed, my guy. We is needed. Or rather, let's just do it like this. Zoop. Let's take this here. This is what A is. A is what you get if you put 1 where n is. The common difference, we have to get it from the first term and the second term, obviously. So let's get T2. So T2 is going to be 5 times 2 minus 2. This is 10 minus 2, which is 8. Therefore, our value of D is going to be 8 minus 7, which is just a 1. Wow. Is it really? Wow, this is looking so... No. Bro. Stop making such dumb mistakes, please. How can 5 minus 3? How can 5 minus 2 be a 7? Hey, that was awkward. This is a 3, meaning this is a 5. So, as you can see, silly mistakes in the exams are very inevitable. So just be on the lookout for them. The only thing is, fortunately, here it was 8 and 7. So it was starting to look shady because I was like, 8 and 7, nah. So anyways, this is 10 minus 2 is 8. 5 minus 2 is 3. The common difference is T2 minus T1, which is just a 5. So we have 5, 3, and 40. So everything in the calculator, let's see what we're going to have there. 40 here over 2. A is a 3. N is a 40. D is a 5. Don't forget these brackets for the 5, otherwise your answer is going to be wrong. So let's see, 40 over 2, it's like 2 times 3, plus 40 minus 1, and there's a 5 here. There we go. That's like 4020. So we have here 4020. There we go. 4020 is the answer. So B says the sum of the first n terms of a geometric series is given by this equation. Yeah, determine the 9th term in the series. So the fortunate thing is, depending on the theory that you know, a specific term in a sequence is equal to Sn minus Sn minus 1. Meaning, for example, if you have, let's say, 3 terms, right? Term number 1, term number 2, term number 3. If you want to find out what T1 is, you're just going to say the sum of the first 3 terms, right? Minus the sum of the, wait. No. If you want to find out what T3 is, yeah, T3. If you want to find out what T3 is, right, you would say the sum of the first 3 terms minus the sum of the first 2 terms. Your leftover would be T3. That's the analogy here, you see. So if we're saying something like T9, see, something like term number 9. Term number 9 is going to be equal to the sum of the first 9 terms minus the sum of the first 8 terms, you see. So T9 here is going to be us putting a 9 over there. I mean, T9 is going to be S9 minus S8. So S9 is us putting a 9 over there. Just like 8 minus 2 to the power of 3 minus 9. This here, you have to subtract 8. You have to subtract S8. So it's like 8 here minus 2 to the power of 3 minus 8. And then this value minus that value. Let's see. 8 minus 2 power of 3 minus 9. This whole thing minus 8 minus 2, the whole thing to the power of 3 minus 8. That's like 1 over 64. That's your answer. That's what T9 is. So yeah, it is what it is. It is what it is. Let's keep moving forward. Question number 5. In the diagram below, we have a cubic function. Passes through the origin. Nice. And then it has another x-intercept and another x-intercept. Very nice. This is going to be an easy cubic function question. So it says A and B are the turning points. Okay, they've given us nice dots over there. Then they said C, O, and D are 3 x-intercepts. C, O, and D, yes. Let's see what the first question is. It's out of 5. So little marks. Okay, I mean, so little space. Okay. Determine the coordinates of A and B. A and B are the turning points. Well, I guess for 5 marks, we don't need a lot of space. Because the equation of G, right, is like this. You see, G of x is equal to 3 to the power of x minus 3x. No, x to the power of 3 minus 3x. So A and B are the turning points. Now what you need to know is to get the turning points of any graph, you have to remember that at a turning point, the gradient is a 0. Here also the gradient is a 0. Now remember, your first derivative gives gradient. You see, first derivative here is a 0. First derivative is 0 because this symbol means gradient. So what you want to keep in mind is in this equation, you have to get your first derivative, right? And then solve for x. So here getting your first derivative, 3 times the number in front, minus 2 from the exponent. You are differentiating. Here 1 times negative 3, removing 1 from the exponent. So this is your first derivative. Where you see gradient, you make this a 0 because you want to find out the x values where the gradient is a 0. Solving for x here, it's not a big deal. I'm going to divide both sides by 3. Our x is a 1. X squared is a 1. So the thing is, since x squared is a 1, you have to square both sides, obviously. Your x is going to be equal to plus or minus 1. So obviously what that means is this side, it's a plus 1. This side, this side is a minus 1. This side is a plus 1. So since they want the coordinates, yeah, they want the actual coordinates. So you're going to put negative 1 and 1 into your equation of your graph of G. and then find the y value. So in the graph of G, let's put in a -1. That's like -1 to the power of 3, -1 here. This is like -1 plus 3. This is a 2. The other equation is a positive. The other one, you're going to put a +1, right? 1 cubed, 1. This is just 1 minus 3. That's like a -2. So here, you're going to say, therefore, A, -1 and 2, B, +1 and -2. Great, great. It looks like the origin is going to be the point of inflection, but yeah, let's keep moving forward. On the Cartesian plane, sketch your first derivative. Our first derivative is just a parabola with a y-intercept of -3. I'll repeat, it's a standard parabola with a y-intercept of -3. So this is like -2, right? So -3 is going to be like down here. And we just see that, remember, this parabola, if you make it equal to 0, these will be the x-intercepts of your parabola, 1 and -1. So your parabola passes through this x-intercept and it passes through this x-intercept. And it looks like that. So all this is based on your theory. Whoa. You see? Goes up, goes up. So the idea is this positive, this -1, this +1. Let's see. So all this, let's see. Let's see. Let's see. So this is okay. This is okay. Nothing crazy, nothing major. Let's move on. C says, determine the equation of the tangent to the original function of this at x is equal to 3. So we have to find the equation of the tangent to the curve. So we have already had a rundown of how you get an equation like this. You see, so getting an equation of a tangent to a curve, you have to remember that a tangent is a straight line graph, mx plus c. To end up with m and c, you start with this format: y minus y1 equal to m x minus x1. x1 and y1 is a coordinate that the graph passes through. And then m is a gradient, you see. So here is just a coordinate. The other one is just a point that the graph passes through. So let's see what we can do here. So all this being done, let's carry on. Let's carry on. So with this being said, right, what you need to keep in mind is you obviously need to find two things about our tangent and our curve. The first set of information is a coordinate where they meet. The second set is a gradient at the point where they meet. So here, since they say they meet where x is a 3, we obviously need to keep in mind that if they meet where x is a 3, it means that we can get the y value also using the original equation of our curve. You see, our original equation of our curve is mainly only going to give us the coordinate, which is x1 and y1 over here. So we need that. And then we also need the gradient. So getting x1 and y1, we have here, let's see, 3 cubed is 27 minus 9. So let's see here. Let's see here. So let's see, 27 minus 9 is like 18, right? 18. 27 minus 9 is like 18. This is like G3 blah blah blah. So what do I need to do now? Yeah, so with all this being said, right, this is your x1 and y1. This here is like x1 is like a 3, y1 is like 18. There we go. That's that. Okay, so carrying on from here, what we now know is at least we have the coordinate that the tangent and the curve pass through. So this is going to be fine. We're going to put that over there and there. See, we're going to put the x value here, the y value there. So now we need a gradient. For us to find a gradient, what we need to keep in mind is we need to find the gradient where x is a 1. Finding out where the gradient is, where x is a 1, we can use the first derivative of our cubic function, you see. Because the first derivative is a gradient equation. This is like 3 times the value in front, is 3x squared. 1 times -3, that's like -3 there. So this is your first derivative, as we know, which is a gradient equation of our straight line graph. So this gradient equation of our straight line graph, we know that we are going to, what are we going to do with this first derivative? We're going to make our gradient a 3. So gradient here, oh no, x value, we're going to make it a 3. This is like 3 times the 3 here squared minus 3. 3 squared is a 9. 9 times 3, 27. 27 minus 3, 24. This is your gradient where x is a 3. So we have our gradient, you see, m equal to 24. So all this being done, you're good to go, you see. You can throw in all those values and then you get your equation of your straight line. So this here is like y minus y1, which is like 18. Gradient is like 24. X, and then here, x1 is like 3, right? There we go. You have like 24x here. And then you have like 24 times 3, right? It's like 24 times 3. That's like -72. There you go. And then there's like y minus 18. Everything on one side. You have 24x here. -72 plus 18. Wait, that -72? Yeah, -72 plus the 18 is giving us a -54. There you go. Quite a strange question, but it looks like the gradient is quite steep. The line here does seem like your gradient is going to be quite steep. So this is our equation of our tangent to our curve. Everything is all good. Everything is all nice. Let's move on to question number 6. Question number 6 says, you start a business and buy a delivery truck for 450,000. If the inflation rate is 6% per annum, how much will a new delivery truck cost in 5 years' time? So this is a compound interest question, you see, because P is the initial amount, I is the interest, and then time is, what are they asking here? How much will a new delivery truck in 5 years' time? So time is 5. I mean, N is 5. So in this kind of a situation, let's see here. What do we have here? Let's see what we have here. Let's see what we have here. So from here, let's see what we can do here. Let's see what we can do here. So P, 450,000. Interest 6%. n is 5. And then let's see what we can do here. Everything, let's put it in the calculator. 450,000, 1 plus 6% per 5. Let's see here. 602,201.51 if you round it up to 2 decimal places. Easy question. It says if you calculate depreciation at 20% per annum using the reducing balance method, what will the value of your delivery truck be in 5 years' time? So remember, this is a new truck. If the value increases over time because of inflation, it's going to cost this much. But then this new truck, its value can decrease if you're using it, obviously. So the value of a truck that's decreasing can be worked out using this formula. See, where P 450,000, I 20%, N is 5, and then let's see, A is left open. So from here, you can just drop everything into your formula. Let's see what the calculator is going to give us. So this here, the 20% portion, right? You always want to make sure that in your calculator, you put the percentage symbol so that you end up with the correct final answer. So let's see here, 1 minus 20, shift percent, the whole thing per 5. Yo, wow, this is like 147,456. There we go. So all this being said, C says, you set up a sinking fund for the next 5 years so that you can trade in your delivery truck and buy a new one by financing the difference with the sinking fund. So what that means is, remember, before we read the rest of the question, your sinking fund is equal to the new value of the truck, right, minus the old value, or minus the depreciated value. Depreciated value. You see, that's what your sinking fund is. So before we even read the rest of the question, remember the new value of the truck is this much when it is, been hammered by inflation. So let's paste that over here. We'll paste. This is what your new value is, right? You're going to subtract the depreciated value. Whatever you have left is your sinking fund, you see, which is the value of what you should have when your investment matures. So let's see here. This is what your sinking fund is, right? Let's just write it here. Sinking fund. There we go. So your sinking fund, before we even read the rest of the question, it's just this amount here. Let's see. There we go. So this is 454,745.51. There we go. Anyways, they said here the bank offers an interest rate of 9% per annum compounded monthly. How much should you put away at the end of each month so that you have enough to finance the difference between the new vehicle and the trading value of your delivery truck at the end of 5 years? The last payment into the sinking fund is made at the end of the 5 years. That's fine, you see. You're just going to have to use your future value annuities formula. So in your future value annuities formula, this is on your formula sheet. What you know is they need you to find out what is your installment for you to end up with this value here. So you have to isolate X. Isolating X here, you can just do that by multiplying by R on both sides first. And then what you do is you divide everything by this big bracket here, you see. So your value of x will be equal to fi divided by this big bracket, because you divide by the big bracket on both sides. So here, fi divided by 1 plus I to the power of n minus 1. This is equal to x. So now when you will put this into your calculator, you're going to say x is equal to f is this value here, 454,745.51. Your interest rate is 9% per annum, compounded monthly. So it's like 9% over 12. And then everything is 9% here over 12. The whole thing, this is 5 years, right? But it's compounded monthly, so it's 5 times 12, meaning this is a 60. And then all this you just have to put in your calculator. Let's put it nicely in the calculator. I see fraction button 454,745.51 brackets 9 shift percent over 12. The whole thing inside this bracket and inside there 1 plus 9 shift percent over 12, the whole thing to the power of 60. And this is minus 1. So the answer here you're going to put here is 6,029, right? 0.18 if you round off to 2 decimal places. So that's okay. You see, this is how much you should be paying. That's okay. Let's move on to section B, where things get hectic. Section B is where things start to get interesting. Ha 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 ha. As you can see, it's literally half the paper. Then you start with section B. It says a person is able to pay 14,500 per month to pay off a loan. The bank offers the person an interest rate of 12% per annum compounded monthly. What is the maximum loan the person can get from the bank if it needs to be paid back over a period of 20 years? So don't be sidetracked by the maximum part here. It really doesn't change much in terms of this being a normal, straightforward financial maths question, which is out of 3 anyways. So it's a loan that you took out. You just need to work out what that loan is or what that loan can be, right? If you're going to pay monthly installments of this much and you're going to pay it off over 20 years. So since we're dealing with loans, you have to consider your present value annuities formula, which is also on your formula sheet. So in this situation, P is what you're looking for. I is 14,500. That's quite a lot. This is the price of what? I don't know. Maybe like a Range Rover before insurance. No, a Range Rover. I'm joking. Never mind. It's a bit less, but let's just carry on. The N is going to be 20 times 12, which is 240. And then what you see here, interest. No, bro. This is X. Come on, bro. Interest is 20% divided by 12. So since we're trying to work out a value of P, let's just throw everything into the equation. So it's 14,500. 1 plus the interest, which is 20% over 12, whole thing over to the power of 240. There you go. Interest is like 20% over 12. There you go. So all things considered, let's put everything in the calculator. Fraction button, 14,500. Then we have 1 minus 1 plus 20%, right? The whole thing over 12, whole thing to the power of 240. This is like 20% over 12, which is okay. So that's okay. So this here, you have to make sure that in your calculator, don't forget to put this with like, a negative exponent. So all this being done, you're gonna get here 800. Yo, it's a huge loan. Yo, but the interest rate is also crazy. Yo, 853,531.31. That's what your p-value is going to be. So this is an okay question. You can just always double check that you. Oh, I put 20. Come on, bro. It's 12. Yeah, see. No wonder why the value does not just. It just didn't look okay. It just seemed too small. So I was like, yeah. Oops. Excusez-moi. Excusez-moi, ladies and gentlemen. But let's try that again. 12%. Because I'm busy putting 12. My mind is still stuck on the previous question, but it's 12%. So I think if there's a comment that came in about the 12%, about the 20%, then oops, I'm correcting it now. So yeah, that's better. That's much better. Yeah, because hey, that amount was just too little. 1,316,881.54 if you round it off to 2 decimal places. Let's move on. If the loan above is taken up by the person, right? What will the outstanding balance be at the end of the 8th year? Immediately after the installment has been made, if they made payments of 14,500 per month. So this is an interesting question. You see, the reason why this is an interesting question, how many marks? It's out of 5. So it's a 5-mark question. You don't have to worry too much about these kinds of questions, because these kinds of questions have specific formulas that you just need to use for you to work them out. So the formula that I'm going to use for this particular question, it's actually your present value annuities formula, but then we're going to use it differently, because when you're going to get the balance of a loan, right, you have 2 ways of doing it, of which the 2 ways are showcased on the main channel, because the main channel on our YouTube obviously has the tutorials that you need to know for you to be. It has tutorials that basically help you to answer these exam style questions, you see. So for example, I know this is this channel, right? But then obviously on the homepage, you can click here, there's Bright Young Brains, that's the main channel. So on the main channel, what you'll notice is if you go to, let's say, playlists, and you look for the financial maths playlist, you'll get it over here just now. Financial maths playlist, there we go. So this financial maths playlist, if you check here, there's a tutorial on the outstanding balance on a loan. So this tutorial on the outstanding balance on a loan, you'll see that there's 2 options. Option 2 is where you make, option 1 is if you have the number of payments that still need to be made. You can say that the balance is equal to this figure here, where n is the number of payments that are left. So in our case, right, we're going to use that version, because 20 years minus 8 gives us 12 years left. So those 12 years times 12 is going to give us 144 payments left, you see. So since we now know there's 144 payments left, what we're then now going to do is our balance, as we said, it is just equal to x, 1 minus 1 plus I, the whole thing to the power of negative n, the whole thing over I. So x is just 14,500. And then here, 1 minus, bro. 1 plus, and then the interest rate is still our 12% per annum, compounded monthly. N is the 144 here. The whole thing, you see, is 12 here over 12. So all this being done, right? Let's put things into our calculator. 14,500, 1 minus 1 plus the 12 shift percent over 12. this whole thing to the power of negative 144, right? So all this being done, we have to say 12% here, right, over 12. So all this, if you put this into your calculator, you just have to be careful, you see. So the balance on this loan is 100, and it's 1,103,988.78 if you round it off to 2 decimal places, you see, as you should. So yeah, that is all good, nothing crazy, nothing major. Let us move on to the next question. Okay, so moving on to the next question, it's question number 8. Question number 8 in this 2022 November final exam question paper for mathematics for grade 12s in metric. By Bright Young Brains, #Levi. Question 8 says calculate the value of x if this is what you're given. Now remember, a sigma expression is literally talking about an SN formula. So in this situation, what you need to know is,
as of this recording, the all access pass, which allows you to access everything on the website, is currently on sale. The sale will give you access to the online courses for a total of 60 days. Now, the all access pass includes the entire syllabus, everything for paper 1, everything for paper 2. You have video lessons that are preloaded on the website, meaning that you'll be able to go through all these video lessons at your own pace, at your own time, without worrying about anyone necessarily scheduling any sessions. Now, the link in the description will take you to the course website where you'll be able to make a purchase of this bundle. The sale is ongoing between the 23rd of October until the 7th of November. Depending on when you're watching this, I suggest that you hop onto the course website and make a purchase. You can purchase directly on the website using a credit card, debit card, or you can make a purchase via the EFT details that are provided on the website. As a reference, you should put in your name and your surname and send the proof of payment to the email address listed on the screen. For more queries, questions, you can always just contact us via WhatsApp. If you would like to find out more information about Bright Young Brains, you can always just Google us and you will be able to find more information regarding what it is that you would want to find out. Depending on where you're currently residing, you can always just contact us via the contact details that you see on the screen.
any sigma expression is in this format, right? You're adding up something, or you're adding up terms that are generated by a formula that will be over here, starting from the value that will be down here, ending at the value that will be up there. Now, in this formula, when you add up terms that are generated by that formula, starting from here and ending up there, this will be equal to whatever they add up to, which is your SN, you see. So in this situation, you have to keep in mind that they're just giving us an SN value here, which is 711. This is obviously an arithmetic sequence. The reason we know that it is an arithmetic sequence or an arithmetic series, whichever way you want to call it, the reason we know that is because n is not an exponent. Normally, if n is not an exponent, your sequence is arithmetic. If n was an exponent, your series would be geometric. You see, the reason we know that is because it says here arithmetic series, because n is not an exponent. That's what you can just look out for. See, so this being done, what we know is we're dealing with an SN formula where this is the formula to generate the sequence. You're starting to add up values from term number 3, you're ending up there. In a situation like this is what you need to do. Firstly, because it's arithmetic, you write out your SN formula. 2a plus n minus 1 with a d. Here is where you need to be careful. Your value of n and d, you have to get those systematically. So let's start with n. n is always equal to where you're ending off minus where you're starting. You always need to add 1 afterwards, always and forever. So automatically our value of n is equal to x minus 3, the whole thing plus 1, which is going to give you x minus 2. There we go. That's n. Your value of a, right, is important. It's what you get when you throw this value into your formula. You see, this goes in there to get a. You see, this does not have to be a 1. So even if it's a 3 right now, that's what you put in your equation for you to get a. Don't take that for granted. So your a is going to be equal to 3 times 3 plus 5, which is 3 times 3 is 9, right? 9 plus 5 is 9 plus 5 is what? 9 plus 5 is 14. That's your value of a. And then your value of d is the common difference. See, d is equal to t2 minus t1. So you can just use your formula for that. You see, you're going to put 1 here and you're going to put 2 also. So here's 3 with 2 here. And then you're going to put the 1 there also. You see, using brackets because brackets make the word go round. This is 6 plus 5, which is 11. This is 6 plus 5, which is 8. So 11 minus 8 is what? 8, 9, 10 is 3. There we go. Let's see here. Let's see here. Let me see here. What am I doing right now? Let me see here. Okay. Okay. Let's see here. Also, please give Sarah and okay. Yeah. So all this is okay. So from here, you have your value of d, you have your value of a, you have a value of n. So you can just throw all that into this equation because remember you also have Sn. Sn is just 111. So you have everything, you see. So putting everything into your equation, you can easily then solve for x here as they want. Sn is 711, and we said it's x minus 2. And then a here is a 14. N is x minus 2 minus 1 there. D is a 3. So all this that we're doing, you see, this is the kinds of things that you learn from things like the online courses. Because this is important, you see, because on the online courses, the idea is you will learn absolutely everything that you need to know about each and every topic in your math syllabus, you see. I mean, as of this recording, depending on when you're watching this, the online courses, the entire syllabus is on sale, you see. It says 17 courses here because 10 of them is like maths, theory, and all that. And then the other 7 is just additional items. So with all that being said, right, if you see here, the bundle here has the entire syllabus, everything here. And what we're talking about now is inside the sequences and series course, you see. The sequences and series course, as you can see, it's like 5 chapters. And the kinds of questions that we're talking about now, it's the kinds of questions that you normally find in like chapter number 3, you see, where you have sigma notation questions here. So see here, more sigma notation questions. But anyways, let's carry on with this question. So all this in the, we're solving for x here. We can see that, let's take it bit by bit. You see x minus 2, you can leave that out. 14 times 2 is 28. This is now going to be what? X minus 3, right? And then this is like x minus 2 over 2. This is like 28. If you multiply inside, it's going to be 3x minus 9. And then this is where you have to be careful. You see, 28 minus 9 is 19. This is x minus 2. 28 minus 9 is like 19. Let's see, 28 minus 9. That's like 19 plus 3x. You see. Now the 117 is the 711 is still just here. So here you just have to keep in mind that you see this 2 here, you can just divide both sides by 2. So that 2 goes away. And then here you're gonna have 1422. You see. And then you have x minus 2 here with 19 plus 3x. This is why you have to be careful because this is together. So don't make the mistake of just multiplying the negative 2 inside. See, you're gonna get that. You're gonna get a problem because remember this is together already. So this is together all the way until the end. Multiplying by the 2 here, it's a valid step, fortunately. So here, we have to obviously multiply out this here. What's the mark allocation? It's a 6-mark question, so it's okay. So here, x times 19, 19x, x times this, 3x squared, this times this. What is negative 2 times 19? Negative 2 times 19. It's like negative 38, you see? Negative 38. So this is like negative 6x, you see? 1422. Then this is like what? 3x squared. 19 minus 6 is 13. And then negative 38, you're going to subtract this number here when everything moves to the one side, you see. So negative 38 minus 1422 is like 1460. Negative 1460. And then let's see here. Let's now solve for x. So x can just use the quadratic formula. Minus b plus minus b squared minus 4ac, the whole thing over 2a. So the big idea here is your value of x, you can see minus b is 13 here, plus minus b squared minus 4a. The good news here is that our value of c is a negative, otherwise we would have had a problem. See, so this is over 2 times a. The reason we would have had a problem is because this value here needs to be bigger than this one. However, since this is a minus and a minus, this is just going to be this value plus that one. So you'll still get something valid from your answer. I don't even know I'm cramming everything here when I have some space here. Let's actually move this over there. Does it fit? If it fits, we drop it over there. Let's maybe change the style to like something like red. Okay. Yo, red. Yeah, red seems to be fine, but it seems to be clashing with the stuff next to it. So let's maybe make it blue. Blue and beautiful. So this in the calculator, let's see what it gives us. So we have here fraction button, negative 13 plus 13 squared minus 4 times 3, negative 1460, 2 times 3. That's like a 20. You see, x is equal to 20. The other one, x is equal to negative 73 over 3. Negative 73 over 3. That's the way we like it. So all things considered, right? X cannot be a negative value. So we have to say this one we disregard it, you see. Therefore, x is equal to 20. The idea is you want to test out this kind of an answer by throwing it into your equation here. It has to balance and give you 111. So you see x, you put it as 20 in your calculator. Your a value, we have 14 over there. Our value of n there, we have our 20 minus our 2, and then minus 1. And then next to that, you have the common difference, which is a 3. So yep, 111. So the question asked us to get x. We got x, so we keep moving forward. Let's go. B here says, in the diagram below, a ball bounces indefinitely. So the whole word indefinitely here, since you're dealing with sequences and series, this should make you think of sum to infinity. Sum to infinity. You see, these kinds of words are similar to the other kinds of words that you can expect to see when you deal with sequences and series questions, you see. Because when you're dealing with sequences and series questions, the kinds of words that you should be able to recognize as words like finite, you see, and infinity, obviously. And then as they have worded out here, indefinitely, it means sum to infinity, it goes on forever. So here it says it bounces indefinitely along the path modeled along. No, along the path modeled below. So it's just going to bounce and bounce and bounce. The heights keep decreasing. It says here, the ball starts at A. And then it starts at A where it is catapulted into the air before bouncing for the first time at B. The horizontal distance between the horizontal distance is equal to B. No, the horizontal distance BC, right, is equal to 3/4 of AB. Okay, so if this distance is like 1, this distance here is like 3/4. You see, 3/4 of the previous one, and then 3/4 of 3/4 is what you have over here, and then going on and on and on, as they have suggested here. You see, CD is 3/4 of the previous one, and then it says this pattern continues indefinitely. So if they're also saying it continues indefinitely, what you also need to know is you have a geometric series where the value of r is between -1 and 1. So here it says each bounce is modeled by this equation. Okay, so what they mean by each bounce, they're talking about, let's see here, you want to be asking yourself, what is x and what is y? What is, yeah, so each bounce is modeled by this equation. You can see this is an equation of a parabola. So they're talking about each parabola can be given by an equation in this format. You see, you can see the turning points are open. However, each of these parabolas have an a value of -1, hence why they're all frowning. It says here, if the ball continued to bounce, it will eventually converge with the horizontal 16 meters from point A. Let's read that again. If the ball continued to bounce, it would eventually converge. When they're talking about where it will eventually converge, keep in mind that anything converges if r is between -1 and 1. So the ball continued to bounce, it would eventually converge with the horizontal 16 meters from point A. So what I mean is, it's just going to carry on, right? On and on and on and on and on and on and on until it's almost like a straight line, right? Because remember, the heights get smaller. The heights keep getting smaller and smaller and smaller and smaller and smaller. So in a situation like that, let us do what we gotta do. So from here, the one thing you can keep in mind is if they now say what they've just said here, right? They're just talking about a sum to infinity scenario where they said if the ball continued to bounce, it would eventually converge with horizontal 60 meters from point A. So this is actually the sum to infinity. See, sum to infinity, because if you add the distance here plus the distance there, going on and on and on and on and on, it will eventually just add up to 16. It says determine the length of AB. So I mean, this is just hypothetical to say if it's 1 here, this would be 3/4 going on and on and on. So to find out the length of AB, right, A is just the first term if you think of it logically, because it's almost like you're adding up terms in a sequence, right, where the distance of AB is term number 1, term number 2, going on and on and on. So the sum to infinity, we know that it is equal to A over 1 minus R. Your value of R, that's going to be quite interesting. But fortunately, it doesn't matter what AB is. You can just label it as 1. It doesn't matter what BC is. You can just label it as 3/4 because the ratio between AB and BC is 1 to 3/4. So this is good enough to get R. You see, R is going to be 3 over 4 divided by 1, which is just 3 over 4. Without even overthinking it, right? The statement here told us that BC is 3 over 4 of whatever AB is, you see. So it's just 3/4 of the previous one. So it just means your value of R is just 3 over 4. So you have your value of R. Let's work out A. What's the mark allocation? 3. Yeah, as expected, it shouldn't be a lot. So here, the sum to infinity, we said it's 16. A is the length of AB. 3 over 4 is what we have here. 1 minus 3 over 4, that's going to be 1 over 4. You see? So 1 over 4 times the 16 here, you're going to have 4, right, is equal to A. So your value of, therefore, AB is equal to 4. That's okay. So this is like 4, and then it becomes 2, and then, no, 3/4 going on and on and on. Anyways, let's move on to the next question. Question 2, what is the maximum height reached by the ball between B and C? So between B and C, well, the other thing is, fortunately, the heights here, we can take note of how the height, remember, this is a parabola. So if the distance here is 4, right? You have to remember that this, you can look at it as 0. This, you can look at it as 4. In the middle is where you are going to get your highest point. Your highest point is going to be somewhere here at 2. So if you know that the x value here is like a 2, you can just get the y value here. That would be the height. So for the second one, it's the same idea. You see, you want to keep in mind the distance from this to that. It's just 4. It's just 3/4 of 4. Well, before we carry on, let's just check what the mark allocation is here. 5 marks. Yeah, this is quite an interesting question. So you have to be careful. So what you know is, firstly, we have to find out what is in the middle of B and C. Once we find out what is in the middle of B and C, right, we can then find its y value. You see, using this formula some way, somehow. So let us do that, you see. So let's see, 3/4 of 4 to get the distance of BC. Let's start there. 3/4 of 4. Remember, of means times. So you can have 12 here over 4, which is a 3. So the distance from here to there is 3, meaning if this is 4, this is going to be 7. You see? Now, if this is 4 and this is 7, between 4 and 7, that's like 3 units apart. So in the middle of 4 and 7, you just add them up and you divide by 2. You see? So you're going to have here 4 plus 7 divided by 2. That's like 5.5, which is 11 over 2. So let's put 11 over 2 here. You see? Now, what you know is, in this equation, you have an x value specifically, which is 11, well, whichever way, the value of p is 11 over 2. The value of the value of q is what we need to get the height. But then, fortunately, you can throw in a coordinate that the graph passes through for you to get q. You see, I'll repeat. They said each bounce is modeled by this equation. So what you know is, for each bounce, right, for each parabola, this is the equation. However, what we are saying is that, all things considered, we are seeing that our x value of our height is at 11 over 2. So our value of p is equal to 11 over 2. And then for us to get a value of q, right, we need to at least get a coordinate that the graph passes through. And we have a coordinate that the graph passes through. We can either use b or we can use c. So let's use b because it's 4 coordinates 0, the coordinate here. So our x value is equal to 4, y value 0. So let's put all that into our parabola. 0 equal to negative half, y is a 4, p is 11 over 2, q is what we're looking for. And then this is like 4 minus 11 over 2. 4 minus 11 over 2, that's like negative 3 over 2. If you square it, you can have 9 over 4. You see, And then if you multiply the half, you're going to have -9/8 is equal to 0. Everything on one side, you have +9/8. You see? So therefore, the height is equal to 9/8. There we go. That's your height of BC. You see? So quite an interesting question. Nothing crazy, nothing major. The fortunate thing is we just have to remember that this is all happening on a Cartesian planar. Let's move on. Let's keep moving forward. Let's keep moving forward to question number 9. Question number 9, we have some more functions questions. Well, yeah. It says here in the diagram below, this equation of W and this equation of T, they are both straight lines, right? They are the axis of symmetry. They are the axes of symmetry of the given graph of H. And then it says here, E is a coordinate given. And then it says ABCD is a rectangle with AB. No, it's a rectangle with AD on the x-axis. So don't be overwhelmed by all this. Actually look at it as a lot of information all at once, because that's literally all it is. Now for 6 marks, it's saying if the equation of H is given by this, find the values of A, P, and Q. So we have to get the equation of the hyperbola basically. So the first thing to look at here is how they've told you that these are the axes of symmetries. The axes of symmetries meet at the point where your asymptotes meet. So you already know where your asymptotes are going to be if you find this point of intersection, which is going to give you P and Q immediately. So let's do that. Let's equate W with the equation of T. You see, so the equation of W is negative x plus 6. So the other one is just x plus 4. Putting these on one side, you can have x plus x, numbers on one side, 6 minus 4. X is a 2, is equal to 2x. 2x is equal to 2. Divide both sides by 2. You are seeing here that the x value where they meet, plus 1. No. I wrote it wrong. Baga. Yeah, it didn't make any sense there, but oops. Plus 4, which will give you a 10. You see, 10 divided by 2 is a 5. Yeah, I don't know why I wrote it incorrectly, but if you get answers right, don't just take them. Just check if it logically makes sense, because this cannot be a 1 if this is a 9. This sketch looks fairly to scale. But anyways, the x value here is a 5. So let's get the y value, because the x value is given as the x value of the asymptote. This y value where they meet is going to give us the y value of the other asymptote. So from here, let's see what you get here. So from here, let's get the y value where they meet, right? So if they meet where x is a 5, you can just throw 5 into any of your equations of your graph. Any of your equations of your graphs, because you want to find the y value here. So let's choose W. In the equation of W, if you put a 5 in there, here's what you have here. The y value is a positive 1. So this has given you P, and it has also given you Q, right? So with that being said, let's keep moving forward, right? So we have P and Q now. To get your value of A, right, you normally need a coordinate that the graph passes through. So in this situation, getting a coordinate that the graph passes through, we have to think strategically, So us thinking strategically, well, let's firstly start off by writing out what we have, Let us celebrate the victories. Not a small victory, so that's why we didn't call it a small victory. So remember, because it's a positive 5 here in the equation here, that's the -5. But then for the y asymptote, you take it as it is, +1. So this is what we have. To get A, we need a coordinate that the graph passes. That's usually option number 1. Another, fortunately, we have it here, E. You see, so we didn't have to look far. So we can throw this as the x value, we can throw this as the y value. So that being said, Y value here is a 2. X value there is a 9. You see, 9 minus 5 plus 2. A over 4 plus 1. The 2 here. 1 goes over, that's a 1. Because 2 minus 1 is a 1. A over 4. Multiply by 4 on both sides. A is a 4. The equation is then h of x is equal to 4 over x minus 5 plus 1. So that's okay. Let's move on to question 2. Question 2 here says, determine the area of the rectangle. Okay, that's interesting. So if you're going to get the area of rectangle ABCD, well, getting the area of ABCD, you may think to yourself, okay, we need like dimensions. And let's see, judging from the marker location, this is going to be an interesting question because firstly, we don't know what A is. We can find it out, fortunately. And let's see here. We can also, this is not a difficult question. It's just a question where you have to do a lot of writing. So because if you get the distance of AD and you get the distance of CD, you're done. Because getting C is simple. It's just a point where one of your axes of symmetries meets your hyperbola. This is just the x-intercept of the para of the hyperbola. So this question is actually not difficult. It's just a lot of marks given at the same time, which is what IEB is all about anyways. So we're going to equate the equation of H to 0 to get coordinate A because we need it. If we at least have this, right, and we at least have that, we have everything. So let's do that first. So making the equation of H equal to 0, solving for x here. Let's see here. The 1 goes to the left. It's going to be negative 1. 4 over x minus 5. And then here over 1. 1 times the 4 is a 4. Negative 1 times the bottom part here is negative x plus 5. Right? The x goes to the other side. 5 minus 4 is a 1. There you go. So that makes a lot of sense, you see. X value here is a 1. So since we now know that the x value there is a 1, the y value is a 0. So that's useful. Getting the coordinate of C, you're going to equate G to the one with the positive gradient, which is T. So that's like this. This is 4 over x minus 5 plus 1. This is equal to x minus 4. Whew. Okay, let's move everything to one side. Let's see here. Let's see. So everything on one side, you're going to have here. No, what we can do, let's take the one to the other side first. You'll see what negative 4 minus the 1, there will be again negative 5. So the idea is when you have something like this, you have a fraction on one side. The other side, you may also now make it a fraction. The reason for doing this is you can now just cross multiply. You see, this times this. You can actually do it like this. 1 times 4 is a 4. The only thing is your next step here, if you're going to square root both sides, right, make sure you put plus or minus on the left so that you can have two sets of answers. You see, the first set, you use the 2 as a positive value. The other one, you use the minus 2. Because remember, your graphs, they meet at 2 points. They meet over here, where you're going to have a specific x value. They meet over there, where you're going to have another x value. So you have to be careful about that. So here, the 5 goes over. It's going to be 2 plus 5, which is 7. Here it's going to be minus 2 plus 5, which is a 3. So obviously, this is the one where the x value is a 3. This is the one where the x value is a 7. So what you now know is the x value here is a 7. We need its y value also. So getting the y value where this is a 7, we can throw it into the equation of t. See, into the equation of t, throw a 7 in there. We're going to have a y value of 3, which is good. You see. So what you now know is the area is just the distance from here to there. Remember, if the x value here is a 7, the x value there is also a 7. If the x value here is a 1, the x value up there is a 1. If the y value here is a 3, the y value there is also going to be a 3. So we have dimensions for this rectangle, you see, just from A and C. So the area, we can see it's just going to be the AD, which is just from 1 to 7, that's 6 units. From D to C, that's 3 units, you see. So our area.
As of this recording, the all access pass, which allows you to access everything on the website, is currently on sale. The sale will give you access to the online courses for a total of 60 days. Now, the all access pass includes the entire syllabus, everything for paper 1, everything for paper 2. You have video lessons that are preloaded on the website, meaning that you'll be able to go through all these video lessons at your own pace, at your own time, without worrying about anyone necessarily scheduling any sessions. Now, the link in the description will take you to the course website where you'll be able to make a purchase of this bundle. The sale is ongoing between the 23rd of October until the 7th of November. Depending on when you're watching this, I suggest that you hop onto the course website and make a purchase. You can purchase directly on the website using a credit card, debit card, or you can make a purchase via the EFT details that are provided on the website. As a reference, you should put in your name and your surname and send the proof of payment to the email address listed on the screen. For more queries, questions, you can always just contact us via WhatsApp. If you would like to find out more information about Bright Young Brains, you can always just Google us and you will be able to find more information regarding what it is that you would want to find out. Depending on where you're currently residing, you can always just contact us via the contact details that you see on the screen.
It's going to be AD times DC, which is going to be 6 times 3, which is going to be 18 units squared. There you go. Nothing crazy, nothing major, just free marks everywhere. Let's move on. Okay. 100. So let's see. B here says on the same set of x's right below, scratch the graph of g of x. Interesting. So if you're going to sketch the graph of g of x, right, it's a 3-mark question. The straightforward idea is to just use the table method in your calculator. So in your calculator, you're going to press the mode, and then you're going to press table, and then you're just going to put in the equation, right? Log with the 2 and then alpha x. So with this being done, it's going to ask you for another equation. You don't have one, so you just press equal to. Where you're going to start, you don't have to put it minus 10. I mean, you could put from minus 10 to 7, but it's going to be too much for your calculator. Or is it? Yeah. Just put like from minus 8 to, no. Because normally your calculator can take a total of like 16 values. So you can put from like -9 to like 7. You see, start at like -9, end at like 7. Step, you can make it 1. Oh, so funny enough, fortunately, this graph, it's a log graph. So everywhere on the left here, you're gonna have asymptote. Your graph is not gonna go there because your asymptote is at 0. However, where x is a 1, no, your asymptote is, we'll just see where your asymptote is. To say that if x is smaller or equal to 4. Oh, so if x is smaller or equal to 4, let's see, in your calculator, where x is a 1, the y value is a 0. So you can put a dot there, right? So let's put a red one. So where x is a 2, the y value is a 1. And then where x is a 3, you have just about 1.5 somewhere there. And then where x is a 4, you have a 2. And then you have like 2 point something there. And then you have like 2.5 there. And then you have like, 7, which is just before 3 there. So the idea is, this is already giving you the idea that your curve, right, is just looking like that. You see, but they said your x value should be smaller than 4, smaller or equal to 4. So you should actually end there. You see, you can even do your arrow here, but then your graph should just end there. You see, you can even leave out that arrow for now. So that's how this graph is going to look. Nothing crazy, nothing major. They say it here now, on the set of x's above, sketch the inverse. So sketching the inverse, you just have to know where your line of inverse is. See, this is your line of inverse. So as long as you know where your line of inverse is, right, drawing the inverse of your graph, you always have to just mirror the points. So this point here, it's going to be over there, you see, because it has to be the same distance from your line. This point here, it's going to be somewhere over there, you see. Now the idea is, you can see if your curve here looks like this, right, this point here, it's going to be somewhere here. You see, this point here, it's going to be somewhere over there. You see, because you see, it has to be a mirror image of each other. So the distance here has to be the same as the distance there. And now remember, if your original asymptote is the one here, right, as you can see, the new asymptote is going to be here where the x-axis is. So the sketch there is just going to look like this. See, that's your inverse of G. The red one is the graph of G. There we go. Let's keep it moving. Okay, yeah, we did this. So it says write down the domain of the inverse. So remember, the domain is the x values that your graph goes to. So from left to right, there's nothing that is restricting your graph. So you can say domain x is the element of R, meaning it has all the x values that are there in the world. It says for what values of x is this equation smaller or equal to 0? So this is quite an interesting question, because as you can see, it's a 2-mark question, so you don't have to overthink it at all. You just have to know the logic behind what they're talking about. So here they're talking about the y value of the inverse of G multiplied by the gradient or the gradients of G, the whole thing over the y values of G. You see? So that's the analogy here, or that's the idea. You see? Here, they're talking about the inverse of G, the y values of the inverse of G. And then here they're talking about the gradients of G. And then here they're talking about the y values of G. So without overthinking it, right, if this expression here is going to be smaller or equal to 0, you have to think to yourself, the only way this can be smaller or equal to 0 is, firstly, if the top part is equal to 0. That's what we can think of. This is more like a wildcard question, in my opinion. I think it's just out of 2 because they didn't want to have people lose too many marks for one question. So let's see what we can do with this question, you see. So the logic behind this kind of a question is, you have to take into account the fact that you have a fraction at the end of the day. It's a fraction. You see, the only way a fraction can be smaller or equal to 0 is, firstly, for this fraction to be equal to 0, the top part has to be a 0. You see, so let's work that out first. Where's the top part equal to 0? But you know what? This is a wildcard question. So the way I'm going to go through it is, it's to say that only a few people may even want to attempt a question like this. But the way you're going to attempt it is, you have to look at 3 things, obviously. But then apart from looking at 3 things, you just have to consider these 2 graphs. So firstly, this is saying the y values of your inverse and the gradient of your graph of G. So what you want to keep in mind is the graph of G, right? Everywhere here on the graph of G, the gradient, right, is always bigger than 0. Is it? Yeah. Everywhere on this graph, the gradient is bigger than 0. The reason why everywhere here the gradient is bigger than 0 is because on this graph, right, the y values are increasing every time you are increasing your x values. So remember, this is an increasing graph, so the gradients are positive everywhere. The other way you can check if your if your graph is having positive gradients is you can just think of walking on this line. You're walking upwards, so it means the gradients are positive. So what you know is this value here is always a positive, always and forever. Now the y values of your inverse, if you look at the y values of your inverse, the y values of your inverse, these are always positive numbers. You see, these y values here, they are all positive y values. So with that being said, right, let's look at the bottom. The bottom is talking about the y values of G. So the y values of G, obviously this one, you have positive y values over here, and then you have negative y values down here. You see, so what we may need to consider here is this particular x value. But anyways, what we know is this can be positive or negative. The top parts can only be positive. So if we are thinking to ourselves of a scenario where this whole thing is below 0, we have to ask ourselves, firstly, the top part, can the top part ever be a 0? This does not have any y values that are equal to 0. This, technically speaking, if you think of it logically, it will never have a gradient of a 0 also, because the curve here will never be a straight line like this. It will always just be increasing even just a little bit. So this thing will never be equal to 0. So we can forget about the part where it says equal to 0. But then the idea is the only time it can be below 0 is if we are talking about the part where this part is a negative. You see, where the bottom part is a negative, that's the only scenario where this thing can ever be a negative value. So what we know is this is the bottom part is a negative only at this specific x value until 0. So we need to find what this x value is, which is just making this equation equal to 0. So the equation of G, let's make it equal to a 0. 0 is equal to log 2 with x there. And then you have here base and an exponent and then the x. So x is just a 1. This is just not to scale, but I mean, we're almost there. So between 1 and 0, that's where this whole thing here is going to be below 0. So you're going to say here your x is bigger than 1, or your x values are actually, yeah, it's going to be equal to 0. Oh, yeah, but this cannot be a 0. So you're going to have to say bigger than 1 or no, smaller than 1, bigger than 0 or smaller than 1. You see, your x values have to be bigger than this 0, but smaller than this one here. It cannot be equal to 1 because specifically at 1, this y value here is a 0, and you cannot divide by a 0. That's this is a 2-mark question. It's a wildcard question. You can see it's only if you're, let's say, like aiming for like high 80s or something. But obviously, more questions like these and how to work them out, you can see here. You can always just log on to the course platform, sign up for the online courses. You can see that you'll definitely be able to go through a bunch of questions like these. But let's move on. Question number 10. Question number 10. It says, you are given the following numbers, right? To use in creating 5-digit numbers. How many unique 5-digit numbers can be created if repetition is not allowed? Very simple, direct question. Digit 1, 2, 3, 4, and 5, right? You have 5 places to put values. So these 5 places, obviously, if digits cannot be repeated, the first slot, you have 5 options. The moment you put a number here, there's only 4 left. The moment you put 1 there, there's 3 left, and then there's 2 left, and then there's 1. So the number of unique codes is just 5 factorial, which is 120. You see? Let's see. Let's see. That's okay. That's okay. That's okay. So with that being said, let's see. Let's move on to the next question. Okay, question number 2 says, what is the probability that a unique 5-digit number starts with an 8 and ends with a 3 if repetition is not allowed? Well, this is quite simple again, because I mean, like, there are 5 slots to consider. So when you visualize this, it's always going to be easy, because look, it says what is the probability that it starts with the 8 and ends with the 3. So before you worry about the probability of that happening, you have to work out the number of arrangements where that is happening. And then you just put it over the total number of arrangements where there are no restrictions. So in the beginning here, if there's supposed to be an 8, it means that there's obviously only one option for the front. For the back, if there's supposed to be a 3, it means there's only one option for the back. So you put a number here in the front, you put a number here in the back, you have used up 2 numbers. Meaning here, you're only left with 3 options. So you put 1 here. Once you put 1 here, you're only left with 2 options for this one. Once you put 1 there, you're only left with 1 option for that one, you see. So the total number of arrangements where you start with the 8 and end with the 3, it's just 3 times 2 times 1, which is just a 6. So the probability of that happening is just 6 out of 120, which is going to give you the following in your calculator. 6 over 120 in the calculator, it's just going to give you 1 over 20. There you go. That's why it's just a 2-mark question. The next one says, it's a how many mark question? It's a 4-mark question. So I guess this may be the only, we'll see. How many unique even numbers greater than 65,000 can be created if repetition is not allowed? Here you have to be careful. The reason why you have to be careful here is because we cannot consider numbers like 65,001 or 65,002 or 3 or whatever, because you see there are no zeros to choose from here. So if they're saying how many unique even numbers greater than 65,000 can be created if repetition is not allowed, the one thing you want to remember is the first number that is bigger than 65,000 that can be considered is technically going to be, remember there are no zeros, right? So it's technically going to be 65,100 and what you may call this one's going to be quite interesting. The reason why this is going to be quite interesting is because firstly, your number cannot end with zeros. And yeah, you know what, let's just not overthink it. Actually, there are 5 slots to put values, right? In these 5 slots, they're asking how many unique numbers are going to be greater than 65,000. So remember, if numbers are going to be greater than 65,000, it means that they can only either start with a 6, an 8, and a 9. So you make provision for that. Numbers that start with a 6, right? And then numbers that start with an 8, and then numbers that start with a 9. Visualize it. You see, 3 sets of numbers. You're going to work out how many you get for each of these, and then you add them up. So let's start with the ones that start with a 6. If a number starts with a 6, there's obviously one option for the front. But if a number starts with a 6, right, the option that you can put here, the number that you can put here, remember our options, it's 1, 3, 6, 8, 9. You see, 1, 3, 6, 8, and 9. So with these being the options, once you put a 6 over here, you have to remember that the next number cannot be a 3. You see, the next number can also not be a 1. Obviously, the next number cannot be a 6 because 6 is used up. So the only option left here is the 8 or the 9. So meaning number of options for this slot is just 2 options, you see. But the big idea is, you see, this is where things really do get a bit tricky. You cannot have two options here, as in considering the 8 and the 9. The reason for that is you have to always work with your restrictions first. So in this situation, we're saying our numbers start with a 6. So the moment it starts with a 6, the other restriction is it has to be an even number. So for it to be an even number, you have to consider what this last position is first before you worry about these here. So for it to be even, the last position can only be an 8 because 6 is used up, 9 is not even, 3 is not even, 1 is not even. So the last slot here, there's also only one option, which is the 8. So when you then think of it like that, all right, you now can think to yourself, okay, there's automatically going to be a 6 in the front, there's automatically going to be an 8 in the back. So once one number is used, there's only 1, 3, and 9 to consider. So when you're now considering 1, 3, and 9, the idea is the number that's going to go here cannot be a 3, it cannot be a 1. You see, because our number would then be smaller than 65,000. So 3 and 1 cannot work for this position. Only 9 can work. So there's only one option for this position over here. So the moment you put a number here, a number there, and a number there, I mean, technically the 6, the 9, and the 8, they are fixed. You see? The only option is the 3, the 1 and the 3. We don't know what's going to go away here. So the moment you have the 1 and the 3 as options, what you do is in this position, you start off with two options. You see, you have two options for this position. The moment you put a number over here, you only have one option for the last one, you see. So your total number of arrangements where numbers start with a 6 is just 2, you see. The ones that start with the 8, you have to consider that the number has to be even, you see. So for it to be even while starting with the 8, the last value here has to be a 6, you see. The other thing is, if it's starting with the 8, automatically it's going to be bigger than 65,000. So we don't have any restrictions for the middle, you see. You will have 3 options to choose from, you see. So 3 options for the first position. Once you put a number here, you have 2 options for the next one. Once you put a number, you have 1 option for the last one, you see. There's 1 option here, there's 1 option here. So these are your arrangements, you see. 3 times 2 times 1, which is just 6. Down here, if it's starting with a 9, it's automatically bigger than 65,000. But for it to be even, there are 2 options for the back here, which is the 6 and the 8. 2 options for the back, 1 option for the front. Once you put a number here and once you put a number there, there's only 3 options to consider for this one. Once you put a number there, there's only 2 options to consider. Once you put a number there, there's only 1 option to consider, you see. You have to make sure that you deal with your restrictions first. So here it's like 3 times 2, which is 6, times 2, which is a 12. So the total of arrangements, it's then 2 plus 6 plus 12, which is equal to 20. Those are the unique numbers that can be made that are bigger than 65,000 and that are also even numbers. So that's how you work out an equation like this one. It's only 4, but you can see there's definitely method to all this that we were doing. It's nothing random. It's definitely particular. So let's move on. B says, in a factory that produces kettles, it is known that the probability of producing a defective kettle is 1 over 65. So 1 in every 65 kettles is going to be defective, meaning it's not going to be working, or it's not going to be good enough to sell. Then they say it here, how many kettles would you expect to be defective out of 19,500 kettles? If 19,500 kettles were produced by the factory. So remember, 1 out of 5 is defective. So the number of kettles that are going to be defective, it's 1 over 6 times 19,500. The reason why you say 1 over 6 times 19,500 is because 1 over 6 of, right? 1 out of 6 of 19,500 is defective. You see, that's the English way of saying it. if you're saying it verbally. But mathematically, when you want to work out the value, it's going to be 1 out of 6 times 19,500, right? This is giving you, no, 1 over 65 times 19,500. This is giving us 300. You see? 300. 2 says the following, right? 2 says the following. If you produced 150 kettles, what is the probability that none of these kettles would be defective? Round off your answer to 4 decimal places. You can see why it's a 2-mark question. Because if defective is 1 out of 65, the working ones, or rather, non-defective.
As of this recording, the All Access Pass, which allows you to access everything on the website, is currently on sale. The sale will give you access to the online courses for a total of 60 days. Now, the All Access Pass includes the entire syllabus, everything for paper 1, everything for paper 2. You have video lessons that are preloaded on the website, meaning that you'll be able to go through all these video lessons at your own pace, at your own time, without worrying about anyone necessarily scheduling any sessions. Now, the link in the description will take you to the course website where you'll be able to make a purchase of this bundle. The sale is ongoing between the 23rd of October until the 7th of November. Depending on when you're watching this, I suggest that you hop onto the course website and make a purchase. You can purchase directly on the website using a credit card, debit card, or you can make a purchase via the EFT details that are provided on the website. As a reference, you should put in your name and your surname and send the proof of payment to the email address listed on the screen. For more queries, questions, you can always just contact us via WhatsApp. If you would like to find out more information about Bright Young Brains, you can always just Google us and you will be able to find more information regarding what it is that you would want to find out. Depending on where you're currently residing, you can always just contact us via the contact details that you see on the screen.
Right, is equal to 1 minus this, which is 64 over 65. So 64 over 65 times 150. These are the ones that are not defective, you see. So this divided by that times 150 is like, they say to 4 decimal places, which is weird, but okay. 147.6923. There we go. We move on. C says, if it is given that the probability of A is equal to X, the probability of B is equal to 0.6 plus X, and the probability of A and B is equal to that value. If the events A and B are independent, find the value of X. It's a simple 4-mark question. The reason why it's a simple 4-mark question is because you just need to know what independent events are. Independent events are events where the probability of A and the probability of B is going to be equal to the probability of A multiplied by the probability of B. So they'll give you a mark for this formula. And then if you put in your values now, you just need to solve for X. You see, probability of A is X, probability of B is 0.6 plus X. There we go. You see? So let's do this here. Multiplying inside, you have 0.6x. Multiplying again, you have like x squared. 0.36 minus x here. Everything on one side, you have x squared minus, x squared, right? Plus 0.6x. And then the x goes again here. The number goes again here. See? So x squared is over here. This plus this is like 1.6x. And then you have negative 0.36 here. You see? Now, let's put all this into the quadratic formula. Because why not? minus b over 4ac whole thing over 2a. So this is obviously showing you the idea that maths is just maths. There's nothing that is, restricted to a specific topic. So b here is like 1.6. You have like 1.6 squared minus 4. A value is a 1. C value is negative 0.36. And then the b value here, the a value here is a 1. There you go. So x is equal to whatever this value is. Let's put it all in the calculator. Negative 1.6, right? The whole thing here is like 1.6 squared minus 4 times 1, negative 0.36, the whole thing over 2 times 1. That's like 1 over 5. 1 over 5. That's the value of x. Because we're dealing with decimals, you may want to just maybe also put it as a decimal, just for the vibes. So to test out your answer, put in your value of x right in the beginning up there and see if your equation balances out. You see. So 0.6 plus 0.2, if you multiply that by 0.2, you're getting 0.16 at the right side. On this side, 0.36 minus 0.2 is equal to 0.16. So let's keep moving forward. Let us keep moving forward. Question 11. What do we have here? It says in the diagram. In the diagram below, C and D represent 2 drones on the ground. Wow. Okay. And then it says the drone at C has a flight path modeled by this parabola. The one at D has a flight path modeled by this straight line. So already this is a 5. Don't take that for granted because of the y-intercept here. And then they say it here, CD, 7 meters apart, and then AB is 2 meters apart. So if this is 5 and this is 2 down, it means this has to be a 3. Again, this is a y-intercept, so automatically this has to be a 3 also. You see, so all this information, don't wait to read questions that they're asking you for you to put this into your, into your question, because it's information that you need to be able to pick it out from when they are talking to you. You see. So let's carry on. You see. So carrying on from here, it says here, if point E, right, is directly above C, calculate the length of EC. Show all workings. Let's check. 7 marks. Yes, C. They're not playing games. But anyways, this is not a difficult question because this is the x-intercept of your parabola. Remember, with your IEB papers, the only thing is they're just a lot of marks all at the same time, but they're not difficult papers, in my opinion. So the thing is, this is an x-intercept, right? So if you get the x value of C, you'll automatically get the x value up here. If you automatically get the x value up there, you can then put that x value into the equation of the straight line. And then you'll have the y value of E, which will give you the distance of EC. But the thing is, the equation of G, you don't have the full equation. So you obviously need the full equation of G. But for you to get the full equation of G, remember, if you automatically get this x value here, if you add 7, you automatically get the x value of D. The moment you have the x value of D, you can just use D and B to get the gradient of BD. So yeah, let's get C first, as we can see we need to get. So in the equation of our parabola, let's make the x value equal to, we need to find the x value where the y value is 0. So let's make this a 0. Let's see here. Making this a 0, let's just use our quadratic formula. See? b squared minus 4ac, the whole thing over 2a. So b is like 2, and then b is like, let's say 2, right? 2 squared. A is like -1, c is like a 3. A value is a -1. So this being done, let's put everything in the calculator, you see. So minus here, -2, right? Plus 2 squared minus 4ac, the whole thing over 2a. So you're getting an x value of -1, which is okay, because this would have been that side, you see. The other one should be a positive number. So let's see what we're going to get over there. It's going to be a +3. Nice. So let's not waste space, because hey, we can see that we might need it. Not we might need it, it seems like we're going to need it. So let us just be careful. This being done, right? Now we have the x value here, right, which is a 3. So now, having to have gotten this x value of a 3, all we know is the x value up here is also a 3, which is okay, but we need to get its y value. Before we can get its y value, we need to get the gradient of the straight line. So let's see. So the idea is, before you can now worry about getting the y value here, you have to just take one step at a time. That's how you go out. That's how you go through these questions. Just do things one step at a time. So now we need the equation of BD. To get the equation of BD, we need the gradient of BD. To get the gradient of BD, we're going to make use of the coordinate D. We're going to make use of the coordinate B. So the coordinate D, we're going to say, this is from here to there, it's 3, right? Plus 7. This is like 10. You see? And then here, x value is a 0, y value is a 5. So these are the coordinates we're going to use for the gradient, you see. So the gradient, which is m, you can just say 0 minus 5 over there, 10 minus 0 over there. This is -1/2 as the gradient. Perfect. Now you can throw in the x value of 3 into your equation of g. So in the equation of g, this is what the equation of g is, right? Plus 5. You want to throw in an x value of a 3 so that you get the y value here. Negative this, 3 over there, plus 5. This is like -3 over 2 plus 5. Let's put that in the calculator. -3 over 2 plus 5. Let's see. That's how you're going to get the distance of EC. Therefore, EC, let's go to 7 over 2. There we go. That's the way we like it. You can maybe write it as decimals, you see, if you want. 3.5 units. That's the way we like it. This next question, it says, a friend of yours says the vertical distance between flight path BD, the vertical distance between flight path DB. Where's DB? There's DB. Okay, the vertical, okay, let's see. They say the vertical distance between flight path DB and the parabolic flight path CA will never be less than 40. Let's just firstly determine what they're trying to say. Oh, okay. What I mean is, you see this flight path here, right? And this flight path over here. What they mean is, this distance here is like a 2, you see? This is like 2, and then it gets smaller and smaller and smaller and smaller and smaller until a certain distance here. And then it gets bigger and bigger and bigger again. You see, until there, until this path here, until this space here. Now they're saying we should show they said here the path will never be less than 40 centimeters. You have to remember our dimension here is in meters, you see. So 40 centimeters, we may want to put it in meters. From centimeters to meters, you have to divide by 100, you see. So this is like 40 divided by 100. It's going to give you 0.4 meters. So we have to show that the friend says that vertical distance between the flight path dB and the parabolic flight path CA will never be less than 40. So is your friend's statement correct? Show all workings. How many marks? Out of 6. Okay, so the idea with a question like this one is, as we said already, we have to look logically here, right? Logically speaking, the shortest distance between our flight path and our parabola, we don't know where it is, but we can easily find it. The way we're going to find it is we have to just compare the y values of our graph of G with the y values of our graph of F. You see, so the distance between the distances here, right, will always just be y values of G minus y values of F. That's the distance that they're talking about. So let's just get this distance and show that it will never be 0.4. So the way we're going to do that is we have to show that the distance will never be smaller than 0.4. So what you do is you want to technically show that the what you call the minimum distance is 0.4. That's what you want to show. So if you're going to show that the minimum distance is 0.4, you may want to consider some differential calculus at some point in time, you see. So with that being said, let us dive into this particular question, you see. So starting off, this kind of a question, it's a 6-mark question, so you don't have to worry too much about it. Let's just get the distance equation first. So the distance equation, we said distance, let's actually say d. Let's just say dx. The distance here in terms of x is equal to the equation of g minus the equation of f. The equation of g, we said it's going to be negative a half x plus 5. Negative a half x plus 5. That's the equation of g. The equation of f of x, it's just this equation over here. You see? And you see, we put our brackets there because those are obviously important. So let's paste this thing over here. Past there. And then we close this bracket here. So that being done, let's see here. Negative a half x plus 5. This, if you multiply inside, it's positive x squared. Negative 2x, negative 3. Simplify this distance equation. This plus 1 is a positive. No, those are not like terms. The x squared does not have a like term. This negative that is going to be this. And then 5 minus the 3 is going to give you a positive 2. This is the equation of your distance. So since this is the equation of the distance, you want to work out where the distance is a minimum. You see, where is distance a minimum? You want to show that the distance is a minimum at a specific x value. And then you need to show that at that specific x value, the minimum distance is a 40 centimeters, which is 0.4 meters. But we have to find out where is the distance a minimum. So we will find out that the distance is a minimum at a specific x value. When we then find out what that specific x value is, we will then be able to throw it into this distance formula and show that the specific distance that comes out is 0.4 meters. So for you to find out where the distance is a minimum, we have to get the x value where the distance is a minimum. So getting that x value where the distance is a minimum, we're going to have to use the first derivative and make it equal to a 0. Because whenever you need to get the minimum or the maximum of something, you differentiate it, you make it equal to a 0. So let's do that. You see, this is going to be 2x minus 5/2. 1 times this is going to be that, and then this falls away. Make this equal to a 0. This is going to be 2x minus this. The 5/2 goes to the other side. And then you have to divide both sides by 5/2. So dividing both sides by 2, the value of x is going to be 5/4, like that. And that's the way we like it. So now you know that your x value is at 5/4. All you do is, in the distance formula, you put 5/4 and show that your distance there is going to be 0.4, as we have stated. You see, 5/4 and plus the 2 here. Let's put all that into the calculator. Squared minus the 5/2, the whole thing with 5/4 plus 2. We're getting 0 point something. We're getting 0.43. Oh, yes. That's good enough, because here we're getting 0.4375. Remember, this is in meters, you see? And then in centimeters, you see here, therefore, distance is going to be equal to 0.4375 times 100, right? If you times this by 100, you're going to get here 43.75 centimeters, you see. And this is not less than 40. So this is the lowest it can go. So it could obviously never be less than 40, you see. So here, therefore, distance will never be less than 40 centimeters. 6-mark question, you get your 6 marks. Let's move on to question 12. But then you see here, all we're doing here, you see these explanations here, right? If you want to know how to explain or how to go through these kinds of questions, you have to visit the course platform. The link to that is in the description. You see, as of this recording, they are on sale. But depending on when you may be watching this, maybe they're not on sale anymore. But anyways, if you do go to the course website via the link in the description, you're going to notice that this is on sale for just $99. Now, obviously, this includes things like the applications of calculus course, which is going to dive into a lot of questions that will help you to break down the kinds of questions that we're currently talking about now, you see. So all this is both caps and IEB compliant. You'll be able to just go through that, you see. I had 40s and 50s in grade 8 to 11, but matriculated with distinctions. True story. Anyways, let's move on to question number 8. Question number 12. It says, below is the sketch, right, of the first derivative. Okay, this is quite interesting. It's a sketch of the first derivative, right? And then it says A and B lie on the first derivative, with C being the turning point. C is on the x-axis. And then it says, if you throw 0 into the original equation, the outcome is a -14. Remember, if your x is a 0, right, it means that you are getting the y-intercept. You see? Intercept. And then it says, if you're throwing in an x value of 2 in the original equation, you're going to get a y value of 2. So this is these two pieces of information are not for this graph visually. You see, this is for the original graph that you had before you differentiated. And then it says here, calculate the x-intercept of the original graph. It's a 6-mark question. So I think we may have to end up using all this space down here also. But anyways, let's see. The idea is you have to remember that your original equation, you don't know what it looks like, but you know that an original equation if its first derivative is a parabola, it means that the original equation is a cubic function. That's like given information that you just need to know. You see, your original equation is just a parabola. I mean, a cubic function. Because when you will then differentiate this parabola, I mean, this cubic function, you get an equation of a parabola, which is what is sketched down here. You see, they have just sketched an equation that is showing a parabola, yes, but then you have to remember the different y values of this parabola are just giving you the gradients of your cubic function. You see, because logically speaking, remember this is just gradients. You see, so this is just a visual representation of how the gradients are going to get lower and lower and lower and lower and lower. The gradient is going to be a 0, and then it gets higher again. Because if this is a smiling parabola, it means that the cubic function looked like this also. It went up, the gradients went up and up and up and up and up, and then the gradients were equal to 0. Well, the way this looks, right, you may actually find out that your cubic function maybe looked something like that. Did it? Yeah, pretty much. Y values are, these Y values are all positive, right? So it just means that your cubic function does not have any negative gradients. So your cubic function might as well have looked like that, as we have said. You see, it's like a weird squiggly looking line where it's like, you know, something like that. I'm sure you've seen something like this before. This is what our cubic function is going to look like. Now, where the gradient is a 0 here, right? It's represented by the, see, this Y value is a 0, so that's going to be like somewhere there for the original graph. But then let's not overcomplicate it too much. Let's break this down nice and slow. It's the last question in this paper, so yeah, we do know it's going to throw some hands, but let's, without worrying about us getting the x-intercept just as yet, you may be thinking to yourself, do we maybe need to get the equation of the graph and all that? So let's move on. Let's move on. Let's move on. Let's see. So with all this being said, given, we have to be careful when we're going to be tackling this question. But this here should, well, one way or the other, right? If you're going to get the x-intercept of this equation, the fortunate thing is the way this equation is going to be originally laid out, it doesn't seem like it's going to be a difficult looking equation. The reason for saying that is one way or the other, if this equation is going to have an x-intercept, or if the original cubic function is going to have an x-intercept, an equation like this would have one x-intercept. So if it has one x-intercept, it basically means that, let's see here. Let's see. Before, without making anything too complicated, right? What we want to keep in mind is this here is giving us an idea of where the turning point is. Turning point. You see, because this is where the y value of this graph is equal to a 0. So if the y value here is a 0, it means that for the original equation, that's where the gradient is a 0. You see. So the other thing is, you may be asking yourself, why do they give us those two pieces of information there, where they gave us two x values that are different, but then they have the same y value? So actually, you know what? The idea is, if they've given you this and they've given you this, they're just trying to say that somewhere at -1 and somewhere at +5, the gradient is the same there, which is okay. So me blabbing like this, obviously it makes sense why this is the last question, because it's kind of tricky figuring out where to even start with this kind of question. But I'm thinking of getting the equation of the graph, but then that seems like a bit of an overkill. But let's see where that takes us, because you don't want to stay idle for too long. In the original equation, what we know is they say the y-intercept is -14. So automatically what we do know is the equation of f of x is low-key gonna be something like this. Plus bx squared plus cx minus 14. Funny enough, yeah, we have then a coordinate that the graph passes through. If you put a coordinate here, 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 I mean x value and the y value, you have 3 variables. That doesn't help anyone. If you're gonna make use of the equation of the first derivative, right? Which is, let's actually work backwards. Yeah, let's get the equation of the first derivative, and then we can easily get this. Of course, bro. So the y-intercept here, we don't know what it is, but we have 2 coordinates that the graph passes through, and we have a turning point. So we may want to actually start off with a format that looks like this. You see, the equation of f of x, its first derivative, we know that it's still just a parabola. You see, so you can start with a format like this one. Reason for doing that is you already know that the y value of the, from here, what we need to do is, luckily for this image that we're looking at, right, we can get the x value of the turning point. We already have the y value of the turning point. It's a 0. The x value of the turning point is going to be in between these two x values. You see -1 and +5. So let's see here. You see, a value of p is going to be in between the -1 and the 5. You see, you want to get the x value between -1 and the 5 because parabola is symmetrical. So this is like going to be a +4/2, which is a 2. So the x value here is a 2, right? The y value is a 0. So we know that here the equation is just ax minus 2 squared equal to the first derivative. To get a, we can just throw in a coordinate that the graph passes through. We can use 5 and 54. So this is like 54. A, we have 5 here. This is like 3 squared, which is a 9, right? 9a, 54. Divide by 9 on both sides. What do we have if you divide by 9 on both sides? Divide by 9, divide by 9. 54, I think that's going to be a 6, is it not? Yep. A is a 6. Okay, good. Perfect. So now the equation of your first derivative is this. You see, if you want to write it out nicely, it's going to be 6 x minus 2 squared. There we go. So the only thing now is from here. So from here, you may want to put it into a format that is quadratic. That's going to help you like reverse engineer everything to get the equation of a cubic function. So you have 6 here. X times x is like x squared. This times this -2x plus 4. And then from here, it's like 6x squared -4x plus 4. And then this is like 6x squared minus minus what? Minus wait, yeah, if you multiply the 6 inside, right, you're gonna have here 6 times 4. That's like 24 minus 24. 6 times 4 here plus 24. So this is the equation of the first derivative. So logically speaking, if you want to get a, b, and c, right? But then the issue now is, even if you do get a, b, and c, now you're gonna have to factorize. Yo. I feel like I went the long dry here, but it feels like it's gonna get us what we need. So let's just carry on. So if our original equation, right, looks like this. Remember our original equation, we said it's gonna look, this is what we need to know about our original equation. It's ax squared plus bx plus c. So if our first derivative has these values here, copy. Let's see what we can do. So I think in this, at this point in time, it's not even a matter about worrying about the 6 mark issue. We just want an answer at this point, you see. So let's see what we can do. So us wanting an answer at this point, we can see that, remember, we can easily get a, b, and c now because we can visually see it from here. You see, paste. So with this being said, Oh, this is wrong, man. This is supposed to be 2bx. That's where the issue is. 2 times b. Yeah, man, come on. This is where the issue was, you see? This is supposed to be 2bx. So 2b here, right, is equal to the negative 24. Yeah. Which is going to give us divide by 2, divide by 2. This is like negative 12. This is b. And then the c is 24. Yeah. C is equal to 24. You see? There we go. So here we can see, therefore, the equation of f of x is equal to a is a 2, b is a negative 12, c is a 24, d is a negative 14. So we can put 2 into the equation and see if this equation is actually giving us a 2 as an outcome, for us to see if this equation is actually correct. You know, so squared plus 24 with a 2 here minus 14. Yeah, this is the equation of our cubic function. So the only funny thing now is making it equal to 0 and then trying to solve for x. So if you want to solve for x here, obviously you could use you can try and use long division. So when you use long division, you have to usually get you actually have to get let's see, it has one x-intercept, so this is going to be quite crazy, because we need to, yeah, we need to find a way. Come on, bro, we need to find a way. Well, let's see if our table method will get us the x-intercept. So alpha x cubed. So I'm just putting the equation of this graph into our calculator, right? And then we're just going to see what it gives us. You see, minus 14. So we're starting, let's start at maybe like negative 8. I always start at like negative 8. I end at 8, and the step I always make it 1. So in this situation, yeah, the x-intercept is a 1. We're seeing that from the calculator. So you can just actually get it by trial and error, you see. So trial and error, you can say let x be equal to 1. So you can have here 2, you put a 1 there, put a 1 there, put a 24 there, put a negative 14 there. Let's see if this gives us a 0. You see? So in our calculator, 2 times 1 cubed, 12 times 1 squared, 24 times 1, negative 14. So yeah, let's see here. Let's see if this is giving us everything we need. So 2 times 1 cubed, 12 squared plus 24 with a 1 there, minus 14. Yeah, gives us a 0. So here you can say, therefore, the x-intercept is where x is equal to 1. So the x-intercept is a coordinate, remember. There you go. Woo! Woo! This paper was quite interesting. Yeah, obviously, as you can see, section B in your IEB papers, that's where it goes down. But this was a good paper. As mentioned, everything we spoke about, everything in terms of like detailed explanations, you can always get that from our course website. From my side, I will catch you in the next video.